Hello, the question for today is a typical car weighs about 1200 Newton. So the weight of the car is weight of the car. The car, which I can write as WCAR, is equal to 1200 Newton. If the coefficient of friction is mu k equal to 0.015, so that means the car is moving, and this is the coefficient of kinetic friction. So we have coefficient of kinetic friction is kinetic friction, which has been written as mu k, and that's equal to 0.015. So we have to find what the horizontal force is needed to move the car with a constant speed of 72 km per hour. So its speed or velocity is, so constant velocity is equal to constant velocity, which I can write as V, is equal to 72 kilometers per hour. So if I change that into meter per second, it will be 72 into 1000 meter. So I have changed this kilometer into meter, divided by, I'll change this hour or 1 hour into 3600 seconds. So it will give us this zero goes, 36 twos are, so it is 20 meter per second. So the constant velocity of the body is 20 meter per second. Now I need to find the force required to move the car and also the power developed by the engine to maintain the speed of the car. So in any case, whenever we have got this weight, it is better to find the mass first. So let us say mass of the car. Mass of the car will be, which I can write as a small m, that's equal to weight of the car by g. So that's equal to 1200 by 10. So I have considered the value of g as 10. So it should be 120 kg. Now in the movement of any body on of surface which has got certain resistance, so the formula that we have is, so the expression for resultant force is equal to mass into A, which is the expression for the second law of motion. And this gives us, or here the resultant force is, it is force applied by the engine minus force of friction equal to mass into A. So which means force applied minus frictional force is equal to mass into 0. So because here V is constant, the velocity that has been given is constant, so that's why we have A equal to 0. So this means F applied is equal to simply frictional force, and that's equal to mu k into reaction force, and the reaction force is equal to mu k into weight of the body, or I can also write it as mu k m into g. So that's equal to 0.015 into the weight of the body is 1200. So this value will give out to be, so let me calculate it. So this value will come out to be, let's calculate. So 0.015 into 1200 will be equal to 18 Newton. So this is just 18 Newton. So the engine has to apply a force of 18 Newton to maintain that constant speed. And now the next factor is the power. So power developed by the engine should be equal to the force applied by the engine into the velocity, because one expression for the power is force into velocity, and that's equal to, that is 18 into the constant velocity is 20, that will give us 360 watt. So this is the answer for the power. So the power of the engine is 360 watt.